Example 6 says use a graph of f of x equals x squared to obtain the graph of g of x equals negative 1/2 times x plus 1 squared minus 2. Alright, so we've done each of these individually, and you even had a couple of them on your assignment where you had more than one thing to do, but I think you could have handled those. That's why I gave you that. But it was like, it might have the plus 1 inside and the minus 2 on the outside, but you didn't have a whole bunch of stuff going on at once here. So first thing is, notice your parent table. It's x squared. And I didn't mention on example 5, but notice when I did anytime we've done what does the numbers do, a, b, h, and k, we never dealt with like the squared or if it had a cubed or anything like that, because that tells us the parent table. So that 2 that I just circled, that square, tells me my parent table. That's all that's good for. Otherwise, we don't use it. Alright, so x squared. And it's the same table we just did. So I'm just going to jot it down here real quick. Took all the x's and squared them to get the y's. And now for this function, let's go through the pieces. Let's see what's happening. Every piece has a job and it tells us something. So what does that negative right there tell us? Let me change colors. I'll write this off to the side there. Yeah, let's do that. Alright, so what does this negative do? Well, the negative tells me it's a reflection across the x-axis. Alright, what about that 1/2? Well, it's not inside parentheses, so we know it's going to be vertical. It's being multiplied times the parentheses, so it's going to be a stretch or compression. What happens when you multiply something by 1/2? It should get smaller. This is not with the x, so it does what it's supposed to. So this is going to be a vertical compression by a factor of the 1/2. And then what is this 1 going to do? Well, it's inside parentheses with the x, so we know it's horizontal. It's being added or subtracted, which means it's a shift. And since it's a plus 1, plus, remember, does the opposite than what we think it should, so it's going to go to the left 1. And then our minus 2. It's not inside with the x, so therefore it's vertical. There we go, it kind of ran together. It's being added or subtracted, so that means it's a shift. Vertical shifts go up and down, and since this is minus, it's going to go down 2. So what is that going to look like in a table so that I can actually graph this? Alright, well, what's going to affect my x's? Is there anything inside with x? And there is. If you look inside the parentheses with x, there's that plus 1. So remember, with x, we do the opposite. So we're not really going to add 1. We're going to subtract 1. Now, is there anything that's going to affect my y's? Yes. This here at the front and at the back. Neither one of those two numbers are inside the parentheses with x. Therefore, they affect the y. So do we multiply or do we subtract first? Well, remember, y does what's supposed to, so PEMDAS says we're going to multiply by that negative 1/2, and then we're going to subtract that 2. Alright, so let's start with our x's. I'm going to take all of these x values right here, and we're going to subtract 1 from them. So negative 2 minus 1, negative 1 minus 1, 0 minus 1, and you can already see the pattern there, 1 minus 1, and then 2 minus 1. And then for our y's, we're going to take all of these y's right here, and we're going to multiply them by negative 1/2, and then we're going to subtract 2. So we got 4 times negative 1/2. I'm just going to put that in parentheses. So that gives us a negative 2, and then we subtract 2, which gives us negative 4. Now, I'm going to skip the 1 for just a minute because 1 times negative 1/2 is going to give us a fraction. And I know y'all don't really like fractions, but let's go on to 0. So we got 0 times negative 1/2, which is 0. Subtract the 2 and we get negative 2. And then we have that 4 times negative 1/2 at the very bottom, which is a negative 2. Well, we already did this one, and we got negative 4 again. So at least this time I know that when I do this one in the middle, my numbers need to be between negative 2 and negative 4 for the first one there that we skipped. But it's not going to be negative 3, okay? This one's not linear. It's not halfway in between them, so you're going to have to work it out. But I did that so that we can see, okay, we know it's got to be between those two numbers. So we're going to take that 1 times the negative 1/2. Nothing else, guys. Change it to decimal if you need to. It's going to give you negative 0.5. And then we're going to subtract 2, which gives us a negative 2.5, which is between negative 4 and negative 2. And then we're going to do this last one. Well, it's the same exact thing, so we already know what we're going to get. But I'm going to double check myself, and I get negative 2.5 again. And then we're just going to have to graph those. Alright, so when I go to plot my points, I got negative 3, negative 4, I've got negative 2, negative 2.5. Remember, negative 2.5 is just in between negative 2 and negative 3. And I got negative 1, negative 2, 0, and negative 2.5, 1, and negative 4. And so here is my new graph. Whoops. Well, I will eventually hit that. There we go. My finger was in the way, I couldn't see it. Alright, now it's a little hard to tell, but remember your parent function. I'm going to graph it up here. I'm going to, even though I did the table in red, I'm just going to use like a darker reddish brown. So when I plot those points, it looks like this. So let's just check it. Did it do what we thought it was going to? So the first thing we said, looking at what I wrote up here in blue, is it was going to reflect across the x-axis. Did it? Did it flip upside down? Yes. It's a vertical compression by 1/2. If I take something from the top and the bottom and I vertically compress it, so I'm going to smash it together from the top and bottom, it's going to widen out. Does my graph look wider? I think so. Then, did it go to the left one? Yes. Look at nothing else. Compare the vertices. Compare this point and this point here. Did it go to the left one? Yes. And did it also go down to? Yes, it did. Therefore, we've got our graph done correctly. So that's how you do it if you have multiple things. And the only thing different is we could have included a b value. And if so, then I'd have took that x minus 1 and I'd have divided it by whatever that b was, just like what we did in one of the other examples. Alright, so good luck on your assignment. Make sure you ask Miss Spates if you need help. You know that she is there to help you. You have no excuse for not getting this done. Have a great day.